This episode of the eeDesignIt podcast is brought to you by Microchip. Adopt SIC with ease, speed, and confidence. All right, guys, I'm Nicolette, and today Brian and I are here to talk power with Rob Weber. He is the product line director of the Silicon Carbide business unit over at Microchip. So we're going to talk all things power as well as what was going on over at APEC. So thank you so much for joining us today, Rob. We appreciate your time.
Thank you, Nicolette.
Why don't you start us off by telling us a little bit about yourself and what you're doing over at Microchip?
Sure. So as you noted, I'm the product line director for the Silicon Carbide business unit, and I have responsibility for our Silicon Carbide die, discretes, modules, and gate drivers. And at Microchip, it's for us all about the system. So really bringing all of those components of Silicon Carbide together, including the gate drive.
So we're focused on power today. Can we start by discussing some significant trends in the industry?
Yeah. So really, we are seeing the electrification of everything. And that electrification is requiring a need for higher levels of power fidelity. Some of the key markets, some of the big markets we're really all familiar with, of course, are electric vehicles and the explosive growth of EVs. But then there's everything surrounding the EV that's also pretty crucial for the infrastructure, like EV charging, and then the impact that charging has on the grid, and the need to improve the smart grid. And then improving new ways to get sustainable energy to power all this through solar, wind, and other methods. So we're really seeing an entire revolution in electricity and power, and the way power is created, distributed, and ultimately consumed, with e-mobility being not the only, but a primary driver of that direction.
So is rapid charging one of the big things there? You talked about, autonomous vehicles. That's probably the biggest thing I would think people are looking at.
Yeah, it really is. And it's huge. And as you see, EV, what are some of the reasons why electric vehicles haven't, let's say, adopted even more quickly than they have in the past? A lot of that has to do with the infrastructure. So you've got this chicken and an egg, right? For people to adopt EVs, they want to know that they can get to the next place to charge their cars.
Right.
So these are both emerging. And then there's government funding in the US, around the world, to fund out the infrastructure for EV charging. And the move to fast EV charging, as you noted as well, particularly as you move from 400 volt to 800 volt bus systems in the car. That's moving to the next and pushing the next generation of fast EV charging.
Is it going slower than expected? Is that a joke? Is that an awful question?
It is a really good question. It is a really good question. Is it going slower than expected? Probably not, but it's not going fast enough. So it needs to kick into another gear for EV charging infrastructure to be built out. And it's happening, with government funding supporting that particularly.
Right. Now, what was going on over at APEC? APEC was just a few weeks ago. I know Microchip had a really big presence there. You guys were showing off a lot of stuff, which I'd like to get into in a moment. But, what do you think that, the key takeaways for the industry were from that show this year? There's always some big takeaway, I feel like, when you leave a show.
Yeah, that's right. So I would say that, the biggest takeaway, and it relates back again to power, APEC is a power show, has to do with this transition in the industry to what's called wide bandgap. And basically, it's this conversion over from the historic silicon-based power conversion material, just basic silicon, to the silicon carbide and GaN, two primary wide bandgap materials. This transition has been happening really over the last 6-7 years. I would say it's now a case today where there was nowhere you went at the show where there wasn't some mention of wide bandgap, the category, and primarily within that silicon carbide and gallium nitride as the new materials for power conversion. It was the absolute clear takeaway from the show.
Nice. Now, you guys were showing off a ton of demos there, right? Was there anything that stood out that you want to tell us about?
Sure. Yeah. So we had a number of demos following through on that theme of wide bandgap and silicon carbide. The business unit also I'm primarily responsible for. We showed a simulator tool that we introduced, the MP Lab SiC Power Simulator. And that's a tool for engineers to be able to start to model the use of wide bandgap products, silicon carbide primarily, in their applications. And this has become important, and we saw it a lot in other places, and all of our competitors and others, because it's a new material, and it requires a new way of thinking about design. Right. So tools like that, simulators like that are important. Further reference designs and evaluation packages. So we had a reference design for an electronic fuse, or an e-fuse, that goes into electric vehicles. Another important demo that we showed. But it's not just about wide bandgap. We showed a new power over Ethernet, or PoE, outdoor switch, to add advanced network and security features for outdoor applications. So another sort of key element of some of the things that we showed at APEC.
SiC is a highly discussed topic at Microchip. Can you provide some insight into the company's development in the SiC technology and its place in expanding the world's power electronics?
Yeah. Thank you, Brian. Yeah, that's a great question. One of course we love to answer. Yeah. So our heritage, Microchip's heritage in silicon carbide, goes back 20 years. We were one of the early innovators in silicon carbide through a company called APT that we had acquired as part of the Microsemi acquisition 5 years ago. So we've been a pioneer. We've been a participant. We've been providing silicon carbide in very high reliability and rugged applications. A lot of aerospace, defense, high reliability required industrial applications. So that's really a big part of our heritage and where we came from into this. When Microchip acquired Microsemi about 5 years ago, all that heritage came. Microchip acquired a company that I was running called Agile Switch, so with gate drivers. And the idea was to put together a full solution for customers. And we have really three main principles that we follow. We're trying to help our customers adopt silicon carbide with ease, speed, and confidence. And if you'd like, I can go into each of what.
Yeah, that would be great.
Yeah, absolutely.
Yeah. So for ease, we have focused on ruggedness and reliability as primary elements of everything we do for our products. And the idea is that if we make the product rugged enough, then customers won't have to design in redundancy that they might do otherwise with alternative, less rugged products. That helps them ease their design. Their design can go faster, easier, less expensive, using fewer components. Second is we focus on speed. We do that through offering gate drivers and other Microchip solutions, controllers otherwise, that really we're in a unique position to do. So when we sit down with an engineer, we can come help solve the whole circuit problem, not just one piece of it.
Right.
And the last piece of the puzzle, and this is one that has become especially crucial as silicon carbide has been taking off, is confidence. Confidence in the supply. Microchip, as a company, very stable company, profitable every quarter for the last 30 years. We've established multiple sources of supply within our ability to supply. So we have multiple epi wafer sources. We have our own fab as well as a third-party fab that we use for fabrication. We've got multiple sources, both internal and external, for packaging. So we essentially bring multi-source capability to our customers by handling all of that internally. And that's something very unique that we bring to the table that we don't see elsewhere. But again, an important element for our customers so that they can move into this new generation of material with comfort that they're doing it with a supplier that will be here for the next 10, 20, 30 years.
Now you also offer not just components, you offer modules, right? Like SiC modules also, correct?
That's exactly right. So we offer everything from the die for customers who want to create their own discrete or module packages. We offer the discrete packages, one of the broadest ranges. We also offer one of the widest ranges of voltage classes, from 700 volt to 3.3 kV. Right. So it makes us unique. And then to your point, modules. We've had module capability for a number of years. We have both industry standard, custom, and we really are one of the few companies that will configure a module specific to a customer need.
So are there any essential design techniques for the SiC modules that we can discuss?
Sure. Yeah, so for modules, one of the key elements there is being able to parallel the die within a module. And that's something that we've invested very heavily ourselves in really trying to understand. If you don't do that sort of internal design within the module correctly, you could end up with ringing, you could end up with a lot of other sort of serious issues that emerge, particularly as silicon carbide operates at much faster switching frequencies. So that's been a key element that we've really focused heavily on in how do you optimize the die layout within the module, and then how do you optimize module to module interaction as well through gate drives. And those are two areas that we focus on and that we really encourage our customers to put that extra level of attention onto, that they didn't have to do quite as dramatically, let's say, with the standard silicon approach that they've been using for many years.
We've heard for a while now that engineers are hesitant sometimes to switch over to the SiC. Maybe it's just lack of familiarity.
Yeah.
So I guess, what do you think that hesitancy is, and what advice do you have for them?
Sure. Yeah. So look, silicon-based IGBTs have been around for 25, 30 years, and people have really learned how to work with these devices. And they've developed a lot of comfort around how to design, how to test, reliability, right? Everything that they've done. Now here comes silicon carbide. It can switch faster. It can operate at higher temperatures, higher frequencies. It's created a whole new world for them that's created a level of discomfort, which is understandable. So, and also,
But isn't that better, Rob? I mean, isn't that better? Wouldn't you think that that's better?
Yeah, it is better. It is better. But also, if you took somebody who's been, let's say, driving their whole life, and they're driving a passenger car, and you put them on the racetrack with a souped-up Ferrari, they're going to be cautious as they make those initial turns.
Right? People just don't like change in general. That's certainly it.
And in power, that's especially true, right? Power is, and look, rightfully so. We're dealing with hundreds, thousands of volts, sometimes hundreds and thousands of amps, right? So, this is, you can't make a mistake in power, because things can go bad really fast. So there is a level of skepticism and caution in the approach here. One of the things that we find is, though, what people do is they try and take the silicon carbide device and put it in the same design that they did for their silicon-based product. That usually does not work very well. And then
why is that?
So one example would be, let's say, the way the devices are controlled, the way they're turned on and off.
Okay.
For a silicon-based IGBT, that silicon IGBT device could handle, let's say, a short circuit condition actually better in some ways than silicon carbide. So they initially go in saying, oh, it'll work the same way. Then they turn it on with that drop in, and the thing goes smoke out. So, they need to learn, okay, wait a minute, we're going to get some of these benefits from the faster switching, but now we've got to look out for some of these other things which maybe aren't quite as robust or the same as we're used to for a silicon-based IGBT, like short circuit, like what's called avalanche, where the device could start to go into this rapid short circuit condition. These are things that also we take care of in our products and in design. But there's a big education process still going on for silicon carbide.
So when engineers are first switching, is their biggest question always around reliability? Is that the biggest question?
It really is, right? Because there isn't as long a history with silicon carbide as there is with silicon. They really, it starts with how reliable, what kind of data do you have demonstrating your reliability, your fit rates, what type of testing, qualification have you done? The level of qualification and the standard of qualification have increased over time, and we're really being put to the test as well to have highly qualified products and to produce those reports and to share those with customers.
Rob, correct me if I'm wrong, but I remember speaking to one of your colleagues over at Microchip, and we were talking about how, when we were having all those shortages and how great it was for you guys to, be able to whip out these devices, so quickly. But the message I was getting there was that a lot of engineers and other companies in general just don't know that you guys do this. It's kind of like they just don't know. Not that there's anything good, bad, and different. It's just they just don't have that awareness. Is that the case?
Yeah, so what we're seeing as the markets emerged, with regard to awareness, a lot of awareness for microsemi, but not necessarily for microchip.
Okay.
So we've had to bring a lot of engineers up to speed on the fact that Microchip acquired Microsemi, and that heritage of silicon carbide
Mhm.
came along. A lot of times when I explain that, I get
There you go. Yeah, I
that's
just did
where
it
it is.
too.
Yeah, you did it as
Oh.
well. It's like,
Right.
oh,
The
okay,
light
that's
bulb
where,
goes off. Yeah.
yeah. So that's definitely helped a lot. But you also raised another question, which is about our availability. Why is
Mhm.
it that we've got availability in a constrained market? And a lot of that has come from the fact that we've adopted this multi-source supply of the basic epi wafer, and that
Mhm.
we've established two fabs for production, and
Right.
that's given us a bit of a of a hedge on the availability that perhaps others have not built into their systems.
Mhm.
Right.
So that's also been a big plus for us, and a big plus for our customers.
Yep.
Um,
It seems like something we should definitely be bragging about right now. So,
Absolutely, yeah.
Absolutely.
all right, Rob, before we let you go, is there anything else about power we should be talking about that we didn't ask you about that you think is really important?
So I think some of it is, where is it going, and is it
Mhm.
only the electric car? Because
Mhm.
a lot of times when you get into these discussions about wide bandgap silicon carbide in particular, people know about some of the more famous electric cars that are based on silicon carbide,
Mhm.
and is it just the car? And the answer is, it is not just the car. It is the entire grid infrastructure. It's renewable energy. It's industrial equipment. So it really is finding its way into a lot of homes. And
Mhm.
also, it's not just about silicon carbide. We at Microchip have focused on silicon carbide, but there's also gallium nitride, another
Right.
important material. And you're seeing those in wall chargers and some other, let's say, lower voltage applications.
Mhm.
But the takeaway is wide bandgap is here. It's here to stay, and it's likely to take over from silicon before the end of this decade, certainly.
Thank you so much, Rob. Thank you
Right.
for joining us. This
Uh,
was fun and very informative.
Rob, tell us where we could find out more on microchip and power.
Sure. So if you come to our website, of course, microchip.com, and if you're looking specifically for silicon carbide, just add a slash and the letters SIC, and that'll take you right to our microchip.com/SIC webpage.